Hello YouTube viewers, welcome to my show Future Friday. In today's episode we're going to take a look at future of substation. If you have checked my last episode, it was on substations. So we're going to look at what are the issues with current substation architecture. The biggest problem is that it's old. When we built many of these substations, they were built like 50 years ago, 70 years ago. So by default their design is based on the knowledge of the people that they had at that time. So at that time it was good enough, but now it's flat out incapable of handling modern loads. So design inherently, as in the backbone itself, is very weak because of the old design. On top of that, is very vulnerable, like in terms of any natural disaster, in terms of hurricane, in terms of flooding, these things are very vulnerable. I mean, like, you don't have to like have tsunami, normal flooding can take them out. So, and the biggest problem is that how we evolved in terms of a civilization is that we used electricity and that's it. Like a company was like, okay, we're gonna build a substation near you and you're gonna have electricity. Okay, everybody's. But once we started expanding, instead of upgrading our system, we started putting more substations. We're like, okay, and then it created a paradox where, like, especially in rural area, is that you have one substation which can barely perform the load needed, and then we ended up in a scenario where it's like either we upgrade the substation, which is very expensive, or buy new land, which is now very expensive, because we did not plan ahead. So at this point, all the substations that exist, unless they are built after 2010, they are very unscalable. Basically, they are built, or let's say it's a substation that's built for 600 megawatt of capacity. That's it, 600 megawatt, done. And on top of that, they are very dumb, and in terms of their measuring resolution. They can measure voltage, they can measure current, but they can't measure a lot of it, and like, high frequency enough, as in data, it will like, last second the voltage was this much, 1 second before that voltage was that much. Now if you are dealing with electricity, spikes can happen in hundredths of a second. So these sort of substation will get damaged by it, but will not be able to detect it. That's why they are classified as dumb. So that's the problem. So we're gonna have an evolutionary change with our substations. We're not gonna have something like when we went from a propeller-based aircraft to jet engine. It's not gonna be like that. In principle, it will be, but we're not gonna notice it. Same way we went from 2 megapixel phone camera to 24 megapixel phone camera to 5 cameras. This will be same, like step by step. The reason for that is cost of change is very high. You just can't go and replace these puppies. They are very expensive. On top of that, you can't practically shut down the national grid. Like, you can't have a city, okay, we're gonna shut down the city because we are changing the substation. You can't do that. So we have to do this while the system is running. So that's another problem. And even though these technologies are not refined, not very good, they are tested. Like, we know for a fact this will work. We know for a fact this will work for 60-70 years. That's something that is very difficult. It's like the chicken and egg situation, where you have like, oh, you want to have a job, but you must have 2-year experience to get a job. That kind of scenario happens. That's why there has been a lot of resistance in terms of acceptance of new technology. And it's understandable. It's like, would you put a multi-million-dollar city on risk because you want to test out new technology? So that's why that is kind of slowing down the adaptation of new technologies. And whenever we're gonna do this, like we have already started. I told you, this is evolution. It's very slow, step by step. It's gonna be very small steps, like, oh, this equipment got changed, that equipment got changed, this changed. Overall, then after some time we'll notice, hey, all our substations has been changed. So this is a very evolutionary change. Do not expect like one day you are driving, oh, this is the substation of the future. It will be the same substation. Over time, its component will get changed brick by brick, and then voila, new substation. So the first thing that's gonna go is our instrument transformers. Basically, if you are familiar with substation, and if you have checked my last video, is that we use basically two transformer. One transformer we have just for measuring voltage, that steps down the voltage so we can measure it accurately, and then you have another current transformer which steps down the current so we can measure it accurately. These two things are very expensive, very big, very beefy, and they put a load on the structures itself also, as in like they can leech off around 1 to 2 amps of electricity just by running it. Basically, you are measuring it, and also you are losing electricity. Now you may not think that's too much, but when you have thousands of substations, leaching little bit just to measure it, that does start to pile up. So we're gonna let go of that. We're gonna let go of that transformer style. Basically, instrument transformer, it's no more, it's gone, like done. So we're gonna replace it by optical. So if you are familiar with how we measure current, is basically we measure something like this. We have a main conductor and then you put a coil around it and you measure it. Nothing fancy there. But optical, hilariously enough, works in the same way. Is that we are gonna have an optical fiber around a conductor, whatever your conductor is, AC or DC, does not matter, and we're gonna send a polarized light through it, as in like the light that you see in your LCD, the light, polarized light, and then it's gonna change the polarity. Basically, let's say light is going vertically, it's gonna get tilted. Basically, the higher the current, the more the tilt is gonna happen. And we're gonna compare the angles. Like we sent 90 degree, we got 75 degree. Now we know the difference. That difference is the current. So that's how we can measure basically very high amount of current without suffering the consequence of having a transformer, having a thing that blows up when it faults out. And these are very fast, as in they can measure in like 1/100th of a second. And there is no magnetic saturation, because if you are dealing with transformers, they have if a spike happens, you can't detect it because transformer will take time to absorb the magnetic flux, so it can't do high resolution in terms of like how many times in a second. Optical, they can handle it. So this is how we're gonna do it. And in terms of voltage, okay, that handles the phase shift, handles your ampere. In voltage, there are two ways. One, you're gonna have something similar to this, and another where you're gonna have what we call piezo system. Basically, your optical fiber will have certain crystals that will change based on the voltage around it, basically the magnetic field around it. It's like same when you have electricity causing mechanical movement, it will have same thing. Basically, electricity will induce physical change into the optical path. So that optical fiber will tell you, like either it will become translucent or it will become opaque, and that way you can measure the voltage without touching the main line, without putting a lot of load. And these equipment right now in use, I already told you, just step by step. Many moderns that we are building right now, they are using this as of now, as I talk to you, they are using this, and these are very good. They are very accurate, they are very good, and they do the job very well. And they don't have basically oil that explodes. They have generally nitrogen just as a suppressant. So instrument transformer is gonna go away. I don't expect them to see in new constructions. So that's how we are gonna replace the instrument transformer. Then we're gonna introduce what we call better design. Basically, when we started the substation, I told you, like, people didn't knew that much, and at that time land was cheap, so the people were expanding as much as they can. So but right now land is expensive, so we have to reduce the footprint. So what we're gonna do is build something like this. Now, hybrid switchgear module, we call this. Now all that it simply means is doing hundreds of things at the same time. So what are those things? Now, first thing is we're gonna use what we call GIS, gas insulated basically switch. Now what is that gas? It could be anything. It could be SF6, it could be carbon dioxide, or it could be custom solution. So the reason we are doing this is basically air gap is very good at stopping electricity. However, you need a lot of it. So basically, let's say somebody tells you, hey, you need 2 point, and it's gonna have, let's say, 200 kV. The 2 point must be at least 2 meters apart to make sure there is no voltage jumping across that. When you are talking about gas, basically you're removing air and you are saying filling that air with one thing, as in be it nitrogen, be it carbon dioxide, or be it SF gas. It allows you to pack those things very close. Basically, the jumping off point, basically you have 2 electrodes, and current jumping from point A to point B becomes very difficult. So in, let's say, in air you have to put them that far apart. In gas insulation you can put them very close and it cannot jump because of that gas is acting as a barrier. So we could do this with oil also, and there are some oil variant, but because oil's tendency to explode when something goes wrong, people don't want to use that much. So we're gonna use GIS as a system, and then this allows us to make everything very compact. So this whole system has hundreds of things in them, like basically half of the substation is in it. What does it have? It has earthing switch. What does it have? It has basically main circuit breaker. It has a current transformer, I told you, the optical one. It has voltage transformer. So all those things combined, that's the main purpose of basically switchyard. That's the main function of a substation. Other than transformer itself, this takes care of everything. So that's the new feature. That's the whole point. This is the old diagram, basically old way of doing it, and this is the modern way of doing it. And this is like to give you a rough idea. From 20 meter of footprint, you're gonna go to 12 meter of footprint by switching to these. So this is the new design. This is what is becoming more and more popular with new designs. And I have provided a lot of video down below. You can see them. So this is the better design aspect of it. Now we also gonna make it smart, because everything has to be smart, because when they were built, people were not relying on electricity to live basically, but now we do. Heck, there are people actually on life support. If power goes out for long enough, they're dead. So, and for everyday basically people, water is directly relying on that, food is relying on that, because if refrigeration unit goes down, we dead. So we have to have smartness in our system, and knowledge is power. If you know how electricity works, if you know like what kind of peak demands you're gonna have, if you can predict it, that will allow you to do better prediction and better management, all those things. That's why we have so many components in the substation to measure electricity, like when the spike is happening, when the current is being drawn, when the voltage dip is happening, when the temperature is affecting our transformer efficiency. All that information really helps us to predict how it's going to happen. You can, like, let's say you collected data for 2-3 years, you can literally predict, okay, in the summer vacation generally the power load on this sector goes down, but increases in the, let's say, water park. And these sort of situation you need to observe for years in order to make a conclusive. Like, you have to tell, yeah, you can call up basically coal power plant or whatever you have, is like, hey, increase your power output because we're gonna soon have a spike. So to understand that, to predict that with accuracy, you need smartness, you need knowledge. Knowledge is power. So we're gonna have hundreds and thousands of sensors in substation and in power plant and entire grid to make sure that we can do much more efficient management of our electricity. So what does it mean for us, basically for you and I? Basically it means brighter future. We're gonna have smaller and smarter basically substation, because nowadays substations that are utilizing gas interlace switch, like these are 100 megawatt substation. If you had told anybody like 50 years ago that you're gonna have 100 megawatt basically substation inside a building, they would have laughed at. But now it's very common. Now some people are trying to achieve like 2000 megawatt going through one enclosed building because of this gas insulated switch. There are some that are not even gas insulated yet, they can still do it. Why? Because they have hybrid switch module where they have hundreds of things going through one object. So we're gonna have very small and smart equipment, and they will be very adaptable. Everything we are building now, we are building on the knowledge that we acquired for years and years. So we know how things break, we know how damage happens, and in the videos description that I have provided, lots of them, please watch all of them, is that there was this flooding happened in New York and the substation was knocked out. So now they are raising the substation by 6 foot to make sure that even in the worst case scenario they don't get flooded. So those sort of scenario, because we learned so much that we can build something that can adapt to the situation, basically the power spike it can handle properly, and it will become more resilient to earthquake, to flooding, to tornadoes. So we have a very good and bright future in front of us. So this was my presentation on basically a substation of the future. I hope you liked it or learned from it. In that case, please click the ad shown in this video, that will directly help me, and I would urge you to press like, subscribe, press the bell icon if you're free, and comment, because I reply to all of them. And if you didn't like it, press the dislike button twice to show your extra disappointment. And as always, thanks for watching.